All right, so wrapping up transformations here, our day 3 lecture. We're going to talk about combining all the different transformations that we have done. We've done translations, we've done reflections, we've done compressions and stretches. And so we're going to talk about what they all look like together. We've looked at this some, but now that we're good at each one individually, let's see what they all look like together. Okay. Now, these are just some tips. I just grabbed these tips from the book. Okay. A couple notes I want to make on this is this vertical shift by K units. Okay. I always do this dead last. And I'll try to label that today when we go through it. But anytime I vertically shift something, K units, that is the very last transformation. I want to do my reflections, my stretches, my compressions, everything before that. Okay. I don't think we're going to run into this. I think the last homework problem, you might need these two, so you might come back and read it and see what to do on it. But as far as assessments go, I don't foresee this right now. Okay. But very last point down here says horizontal and vertical transformations are independent. It does not matter whether horizontal and vertical transformations are performed first. With that being said, I do want to let you know that this is a totally true statement, but you will see me do all my horizontal stuff first. It just makes more sense in my head to do it first, and we're just going to try to work them all the same way. And then we'll do all of our vertical stuff second. So everything that's inside the function will be first. Outside the function, we'll do it second. So let's just come up with our own problem. It says write a function g for function f after it has been through the following transformations. So I need a parent function. Someone holler out a parent function for me. Cubic. Oh, cubic. Beat you. So cubic function. Let's see. What all do we want to do with the cubic function? Let's reflect over the x-axis. Let's go down 7 units. And let's do a horizontal stretch by 3. So what I'm looking for is a new g of x function, okay, that comes from this old f of x. So we worked ones like this, just not combining it all. So this is where I want to take my x and my cubes, and I leave a lot of space around it so I can put stuff on the inside, outside, multiply, add, subtract, everything I need to do. So first off, reflecting over the x-axis. Reflecting, that's a negative sign, correct? Over the x-axis, which way is that? Left, right, up, down? It's up and down. Everything up and down is outside the function, right? So what am I going to put outside the function? Just a negative sign. Everybody with me? Okay. Moving down 7 units. Do what? Ooh, yeah, inside or outside? It's outside. So remember, everything outside makes sense. So going down 7. Next, we get this horizontal stretch by 3. I'm trying to throw you off on this. Now, it's horizontal, so I need to think inside, right? So I'm going to go ahead and make myself an inside here. And it's stretching. Is that multiplying or adding? It's multiplying. We're changing the shape of it. It's going to be multiplying. So where do I put that 3 at? Inside the function. So is it? Ooh, 1/3. Why is it 1/3? Opposite, remember? So I throw a 1/3 right here in front. Remember, everything inside is backwards. So you would think a horizontal stretch by 3, I would pull it apart and make it 3 times fatter, right? But so you would think put just a +3 in there because it's 3 times as wide, but actually it's going to be the reciprocal of 3. I'm going to turn it around. I'm going to rewrite this so it just looks a little better. Princey doesn't look better, but anyway. that would be my answer on this. Okay. Yeah, one of these tomorrow, one of these on Friday on your test. Let's do it again. Let's get a new function. Josh, what was your function you wanted to do? X cubed? Oh. Did someone else say something different? X? That's too boring. Absolute value. Let's see absolute value. Absolute value of X. Let's do a, it's going to be vertically compressed by 1/3 reflected over the, let's not do a reflection. Sorry. I want to go right 7. And let's go up 12. Right 7 units, up 12. So I'm looking to rewrite it as a g of x function. I'll make my absolute value of x, leave some space around it so I can add, subtract, multiply, whatever needs to happen. So if I vertically compress it by 1/3, where does that 1/3 go? Outside. Do I do the reciprocal thing again? Do I? So 3? Hobbs is saying no. And then he's saying, oh, wait a minute. Don't say my name on the live recording. 1/3, Elijah? Where at? Inside or outside? Everything outside makes sense. I don't have to change anything when it's on the outside. So yeah, 1/3 on the outside. All right, right 7. Where do I put 7 at? -7 inside, -7 right here? Oh, x -7. Okay. It's opposite. You would think right 7 would be over here at the +7. It's opposite. Up 12. Plus 12. Can we do this tomorrow? I will make sure you know all of these transformations and combine them. I've got to do them all within 3 questions on the test Friday. So, all right, let's do a couple graphing and then that'll be it for today. Let's go use our square root function. Square root. Let's throw a negative there. Square root 2x plus 1. Now, in your homework, and on your test, I'm going to ask you to list out your transformations on the side in words. So that way, if I'm kind of wondering what you're trying to do on your graph, I can go back and read it, and I can give you your credit on it if I know what you're trying to do, as long as your graph halfway looks like what you're trying to do. Okay? So let's start with my basic parent function. This parent function is the swoop. Remember when that was hard, knowing all these? Told you we would know them. The swoop. The swoop. Remember my rules. I want to do inside the function first. So I look at that 2 inside the function. What is that 2 doing to my swoop? Stretching it? Shrinking? It's opposite. It shrinks it. So we have if you just write horizontal shrink, that's good with me. It's actually being horizontally shrunk by 1/2, but we're just going to take this arrow and push it back. Okay. Then shrunk back. I believe the pencil. Ideally, everything's half the distance back towards the y-axis. Now remember, my rule, this guy is always last. So the next thing I want to take care of is that negative in front of my square root. That negative reflects my swoop which way? Okay, over the x-axis, good. Reflect over x-axis. Okay, so now this red swoop, still been shrunk back a little bit, is coming back this way. Okay. And then I say I've done the 2, I've done the negative, I've made it to the +1. That +1 is going to do what? Left 1? Up 1. Up 1. It's outside the function, it's outside the square root, so it's going to send everything up 1. So my swoop is going to be upside down. Let me do it in green. Now notice I've used a dotted line. That means that Mr. Lele, don't grade those lines. Grade this one that's going to be solid right here. So I got a swoop. That would be full credit. My pen's off a little bit. It should be at 0, +1. Any questions on that? Let's do one more. Riley, give me the hardest parent function you can think of. The most difficult one that we haven't done yet. Let's just do x squared. We did cube root. All right. I'm just trying to hit all the, yeah. I don't know, you want to do that one or absolute value? Your choice. Absolute value, all right. We do absolute value. Absolute value. Let's. Was that your absolute value music? Absolute value. Dun, 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 dun. All right. Okay, let's do 4. Riley, you want a reflection in it? Okay. Riley says, bring on the hardness. Okay. Absolute value. What is that crazy looking parent function look like? The absolute value. It's the V. The V. Let's go ahead and draw the parent function because I put it's called a non-rigid transformation on it. It means I need a basis of how wide you made that V because we're going to shrink or we're going to compress or stretch it in some way. So I want to see which way you are shrinking it. Okay, so starting on the inside, I'm going to make a little note to myself. This guy is last every time. So let's start with that -3. What's that -3 going to do? Write 3. 1, 2, 3. Dotted line. Don't grade this line. Okay, I'm done with all my horizontal stuff. Okay, now remember, I've got to treat this 4 and the negative as 2 separate ones. I just work my way backwards. I'm going to go ahead and do the 4 first and then the negative. So the 4 stretched by 4. So make it so it's 4 times as wide. 4 times as tall, right? So I'm going to make it, it's going to be taller. It's going to be stretched out 4 times. Ooh, that is a skinny, skinny V coming up. All right. If you draw it like this, I can check your work as you go. It's a lot easier. Now that negative in front, which way is it going to reflect it? It's going to come down again. It's up and down. So my skinny V now is coming down. Okay, and finally the +1. Everything goes up 1. So I'm going to have a skinny V that comes up to the point 3, +1. Full credit. If the 4, yeah, good question. So if the 4 was positive, I would not have reflected. My V would still be pointing up. Yes, good question. Any other questions?